Okay. Well, do you want to deal with the lights?
Is that alright for the camera?
Yeah, so far, aye. Don't put them all out.
I can't put them all.
Aye,
You'll
right.
see,
Right.
you'll see what he's running.
Okay. Right, if you go to the next slide. Here's a NEA that was discovered in 1989, and this pic was taken by radar when it came back on 8th December 1992. And again it came back in 2012. Next. And here it is passing 2.3 times the moon's distance as seen from Earth. Next. This one was taken by the Chinese moon probe Chang'e 2, which passed fairly close to it. It's probably the best as it passed only 3.2 kilometers from it on December 13th, 2012. According to Chang'e 2, it is 4.26 times 2.03 times 1.7 plus or minus 0.08 kilometers across. As an Apollo asteroid, it orbits from near us to out beyond Mars. Next.
How often does it pass close to Earth?
Every few years. Here's a wee look at what hits us over around 19 or 20 years. Most of these are pretty small, and unless one lands in your back garden, the chances are you won't hear about them. Next. So, what should we worry about? I'll give you a few more moments to read this. Are you ready to move on?
Could somebody explain those three terms, because I don't see anywhere that explains Apollos, Amors and Atens.
Well, that's the types of asteroids.
Yeah, but what,
I've got a slide
good
to
words?
explain that. Yeah, I'll explain that later.
That is going to be explained.
Yes.
Okay.
Can we go to the next slide? At the moment, we don't have any dire warning, but there is still the possibility we could be smashed out of existence tomorrow, so the sooner we get our politicians paying attention, the better. In this diagram, the blue planet orbit is Earth, and the red planet's orbit is Mars. So you'll note that the three classes of NEAs are Atens, which are light blue or green depending on your eyes, which are mainly within Earth's orbit but do cut it. Apollos, purple, which cut both our orbit and Mars orbit. And Amors, orange, that cut Mars orbit and come near but don't generally cut ours. Now do you understand these three terms? Okay. Next, here's another diagram. This shows how easy it is to get to NEAs compared not just to Mars but even to the Moon. Okay, next. So why should anyone want to visit a NEA? Apart from orbital names, there are three makeup types. This is a bit of what is called a C-type asteroid. They are thought to be most common asteroids and rich in water, which, as you'll appreciate, will be valuable for future space activities. Next. This is a bit of what is called an X-type asteroid, though some people call them M-type. These are the least common type, thought to be dense and rich in minerals. There is one such that is thought to have more platinum than all the platinum ever mined on Earth. An asteroid that has all that much platinum. Next. This is a bit of an S-type asteroid. They're a mix of rock and metal and are mainly thought to inhabit the inner part of the asteroid belt and be common among near-Earth asteroids. Next. When this particular asteroid that is talking about here passed within 17,100 miles of our planet, celestial mining firm Deep Space Industries calculated its raw materials were worth an estimated $125 billion. Sorry, billion pounds, $195 billion. Another firm, Planetary Resources, has calculated that another asteroid out on the main belt called Germania is worth 60 trillion pounds. About the same GDP as the whole planet Earth. And that's just one asteroid, but it's way out in the asteroid belt. That's the problem with Germania. It's too far away for any immediate visits. Next.
Why is that calculated to be so high?
It's a big one. It's over, I think it's about 100 miles across or something like that.
Right, so they have some idea of the composition.
But they know what its composition is. Yes, they've been analysing it with these spectroscopes and whatnot. You know. Here's an artist's impression of what that asteroid, the one that passed through the geosync in that previous diagram, might have looked like close up. Next. Here's a view of how it passed looking down from above our North Pole. And you'll see it comes inside the geosync and out on the other side.
It's nowhere near close enough to heat up. The artist's impression is totally wrong.
No, yes, the artist's impression is wrong. Next. Deep Space Industries vehicle might look like this en route. Next. Here's a breakdown on which part of it does what. Next. Planetary Resources is the other main US mining company. This is their proposed vehicle. Next. Here's a pic of their boss with Deputy Prime Minister of Luxembourg, who have just put a chunk of money into their coffers. Luxembourg is also contributing to Deep Space Industries. Next. This is a pic of a simulation of NASA's asteroid redirect mission. The kind of thing that might happen to it if US politicians ever allow it to fly. That'll depend, as Robert was telling us a few minutes ago, on who wins in the election and what happens. Next. ESA is going ahead with its asteroid impact mission, which is supported by Germany, Belgium, Spain, and Poland, and Portugal, and Romania. Oddly enough, Britain is not involved.
You're not in it.
Sorry?
UK not involved in
UK
it.
is not involved. However, you will be interested to know is that apart from these two main companies I've mentioned, DSI and Planetary Resources is really backed by the Planetary Society, but there are also lots of several other companies that are in the business, but they're mainly small, and there is at least one British company involved in planning to mine asteroids. Sorry, I don't have its name to hand, but there is one. If you go into the space info list, you'll see a number of possible things there. That's the end of the PowerPoint, so you can switch the PowerPoint off.
Yeah, what's the space info?
It's a shortcut to Neo Info or something like that it's called.
Neo info. Oh, yeah.
Yeah.
Shortcut, right,
Yeah.
okay.
And there's a number of files in there. And we can open some of them if you want from time to time, if you want to check on this or that or whatever, because I've got files for various things. I think I've got one that mentions the number of companies.
We might have issues putting this onto YouTube because of the musical soundtrack. I do
Yeah.
not have the copyright for that music. And what happens is that it
What
now
soundtrack? You
detects
mean next door?
next door. The issues with Duncan's event, the copyright.
You don't need to open
It's not our fault, we're not broadcasting it.
You do not need to open that, because
Right.
that's composition. We've dealt with that in the talk I just gave you.
Yeah,
That's just
presumably
a
that's a
repeat of
bit more.
info that you've already got. Can we see a list of the files? Right, now what have we got there? Yeah, well, there's an envelope with stuff about DSI, there's an envelope with stuff about planetary resources. No, come out of that for the moment. Come out of that for the moment. Right. Value, that's got the $1 billion, $1 trillion stuff and $1 billion stuff. Asteroid resources.
You guys okay? Yeah?
It's not too noisy for you?
No, it's fine.
It's okay.
It's fine.
Come down a bit. Let's see. Composition, which is dealt with. Impact mission. Well, that there's actually ESA have a very good video of that, but I don't have a copy of it. I'm sorry. You'd have to go to the ESA website to see that, but there is a very good video of how that impact mission would work. It's the Didymon is a twin asteroid, or it's an asteroid with a moon, if you like, and they're planning on landing something on the moon and on the main thing.
Right.
And analysing and this kind of thing, but it's actually a very good mission. That it's a pity I don't have that video, because that video explains it very, very clearly. But
Sorry, what's the name of that system again?
Asteroid Impact Mission. It's
No,
quite simple.
the asteroid itself.
Yes.
Didymos.
Didymos.
Nimmo, sorry.
That's the name of the moon they're planning on going to. Didymos double asteroid in 2020.
Oh, there it is.
And this is the
Didymos, right.
European
Ken-
Space
Ken Dodd.
Agency is doing this.
Oh, yeah.
But that is, I think there's 2 or 3 pages on that there. You can look at that if you want. What I was looking for was another file. There's a file there somewhere on that list of files which has details about different companies that are involved in it. This is all about this ESA mission. That's that thing. Right, I think it's the mining one.
Mining.
Yes, that's the one you're looking for.
Double click it.
No, I've got it. It's just
That's it, yeah. If you go down a bit, I think you'll come to a list of American and other companies. Well, that's what's on them, what they reckon is, they've checked that some of them have got. There's whole piles of stuff here. That's the problem with this. These files, some of them are very long, and I think this one is several pages.
But if you want to dig into it, you'll find stuff there.
Move down.
Yes, feel free. But as you'll note, there have been several different analyses at different parts, different places by different groups. Actually, one of the things I think, one of the reasons Elon Musk is interested in space is probably because these electric cars that Tesla makes use lithium to power them. But lithium isn't the only thing they use. They also use cobalt. And both lithium and cobalt are in short supply on Earth. Up there, cobalt is all over the place, we know that. We don't know about lithium, but it might well be lithium. And it's certainly very worth investigating. But that, to turn all the cars on Earth into electric cars using lithium batteries would use more lithium than there is on the planet Earth. A lot more. And also a lot more cobalt. So that is one thing they might get from space and bring back right all the way down here, apart from using things in space. But most of the asteroid mining, I think, will be used for construction in space, metals and so on. I'm surprised that the price of cobalt on the mining shares hasn't gone up, but lithium's gone sky high because people have realised that that's going to be in short supply, but cobalt hasn't quite.
Right, what about molybdenum?
Sorry?
Molybdenum. Molybdenum. You use it in the magnets.
Well, that would be useful. Yes,
Molybdenum, that's what you say.
I don't know if it's in short supply or not. I must say it's not one I've checked. I don't know on that one.
What's the interplanetary transport network?
So I've not heard of that one, no. So I know all about what direct Hoffman trajectories are. What's the interplanetary transport network, Andy? I've not heard of that, you know.
Well, I don't think it's yet been created.
Well, right, is it like cycling spaceships and stuff, like a transport infrastructure in the solar system? Is that what that's referring to?
Yeah, I think that's
So, I mean, at the moment you're looking at the box there, like Earth surface to low Earth orbit, you need a delta V of 8 kilometres a second. From low Earth orbit to near Earth asteroids, you would need another delta V, that's a rocket burn of 5.5 kilometres a second. I don't know for how long that burn is. From low Earth orbit to the lunar surface, you need a delta V of 6.3 kilometres a second. And from low Earth orbit to the moons of Mars, 8.8
8 kilometres a
a
second.
second delta V. One of I think the asteroid redirects mission thing is just an absolute nonsense now. And one of the suggestions now is instead of doing that, use the same, solar electric propulsion, and use it for a direct flight to the Martian moons, rather than going to an asteroid and bringing a stone back.
Well, the
It could
Russians
go to.
are planning to go back to Phobos again.
Uh-huh.
Yeah,
Right.
I don't know when they'll get there.
So
Well, this is, shouldn't delta V, shouldn't be that kilometres per square second?
that's just kilometres per second.
squared.
I don't know, Bob, that's just kilometres.
Well,
I take it 8 kilometres a second.
so it should be kilometres.
The escape
KMS
velocity
minus 2.
on the Earth is 7 miles per second, you know.
Right, move it in.
But they don't use Holman transfers nowadays. They've got quicker ways of doing it.
Well, how do they?
That's probably what they mean by
How do you,
interplanetary
what's the
transport.
quicker? What's the quicker
network.
ways? What's the quicker ways doing it? You know, I mean, the only
Holman orbits are the cheapest way of doing
Right,
it, but not the fastest way of doing it.
if you had nuclear propulsion, we could do it well.
No, it's a matter of still orbits. There are faster orbits, but you need more power to use them, sort of thing.
I thought that's what the Hohmann transfer was, an orbit round the sun. The Hohmann transfer, you put the spacecraft in an orbit round the sun, and that orbit is at an area where it coincides where eventually you catch up with the planet.
This is the idea,
and then
that is
assisted.
the easiest way of doing it, but there are other orbits you can use.
Yeah, then the other
You'll get there
assisted.
quicker, but you need more power.
Yeah, but assisted Hohmann is when the planets, like Voyager, when the planet's on the right positions, that can speed it up. But at the moment, the only way that we can get any faster is we need some kind of advanced propulsion, like nuclear propulsion or some other exotic propulsion. I'd interested to find out more about this. What was it again? The solar system what was that? Transport system. What that's about. I mean, there was one proposal you talked about many years ago: firing lasers. So you like in solar sails and stuff, they'll fire laser beams in the solar, like a railway, so that you're propelled along that laser beam. You could have an Earth-Mars transport, like the Glasgow subway, with cycling spaceships orbiting the sun and all between the Earth and Mars. So if you put maybe 4, and they're like 5 months apart, and you get these 4 spaceships orbiting the sun, it's like a railway system, so that you can go from Earth orbit onto it when one approaches the Earth, and you stay on it till you get near Mars, and then you drop off it, and then it goes on, and people can jump on and like a railway.
This is supposed to be a discussion.
Well,
of asteroids, not
but-
Mars.
Well, again, it's important to near Earth asteroids. How do you get to them?
The next meeting in this series is Mars,
No.
and that's when that should be
No,
coming
but
up.
it also applies
Duncan used to
to
point out with the idea of swing stations, well, it takes just as much energy.
yeah.
But I said, well, that's not the point of the swing station. The point of the swing station is you put life support and things in
Yes.
there. You don't,
Yes.
you don't continually
Aye,
have to
that's
accelerate
right,
the same mass.
But the same thing can be used for missions to the asteroids as well. No, it's not just for Mars, you know.
Well, there's no point in a cycling spaceship to an asteroid unless there's some purpose at that asteroid.
Mining,
Yeah.
mining operations.
It would be the way that you would do it.
Uh-huh.
Is to load it onto, you know, load your cargo onto swing stations and then unload it at the other end. Load it onto something in its own orbit and then unload
If
it
you're
again.
spending time on one asteroid, yes, I do agree, yes.
It's like the big Tesco train that goes to Dundee with the Class 66 loco or the Wagons.
Uh-huh.
And then it's
that whole
offloaded.
thing could be done robotically, I think.
Yeah.
Yeah.
But that would be the cheap way of doing it.
Yeah.
As opposed to, you know, a spaceship for every load that you otherwise
Right.
you need to, you know, have a mission for every load
Every-
that you bring back.
You use a rocket all the time, it costs a lot of money. Now this, I'm very interested in this one. France, the public space telescope Sentinel. And when we were at Autographica a few years back, is it Rusty Swigert of Apollo 9 was there? Is it Apollo? And he's right into all this. And he gave a talk about near-Earth objects and the threat that they. And I suggested, why can't we? What we need to do is put a telescope up at the Lagrange point that is looking, because you can't see stuff coming out of the sun.
Yeah.
You know, what was that? So they've got this telescope out of space. It's a particular orbit to watch for these things. And he said that is what I want to do.
You want to be watching between the Earth and the Sun.
What I'd suggested is exactly what he wants to do. So that's at the ALS Sentinel to launch 2017-2018. Partner orbit similar to that of Venus will help identify threatening asteroids by catalogue 90% of those with diameters less than 140 metres.
Well, they have a mission at the moment called Scout, which just spotted an asteroid 5 days before it got here. That was just the other week that one passed. Indeed, there was an atom passed 4 times the distance of the moon last night, about 7 o'clock last night, I believe. I didn't go out and try and see it. You wouldn't have seen any.
Well, you might have seen it. You would have seen it if you knew where to look. You probably need a telescope, binoculars, but you probably
And
know.
how do you get rid of the clouds?
Oh, right. Well, it was clear. Assuming it was clear, you know. It was
quite
clear in
last
Paisley
night.
last night.
Yeah, it was actually clear, yeah.
When I arrived down here yesterday, it was clear in
It was too
Paisley.
cold for me to go out though, anyway. Anyway, I wouldn't have seen anything in Rutherglen for the street lights. There's a great big powerful light outside my house, which is good for chasing bugglers away. If salesmen are trying to phone me in the middle of ASTRA meetings, the phone is getting switched off.
I have started copying the airtray thing at the Mills Observatory. I now tell people no flash photography and could you please turn your mobile phones off? Because last month at the planetarium talk I had somebody's phone going off in the middle of my lecture, so I'm not having it. So I'm telling them to I've shut my phone down for you, Andy. I said shut all phones. You get that airtray, William Laurie's the number, he was the number 1 culprit for it.
This was quite a long document, Andy.
Well, that's what I said, it's several pages, so there's an awful lot of info in there though.
I think it's good.
I'm not reading it.
about 20 pages this document. Another thing that people would be best to look at themselves online,
Yeah.
then, you know, because it's
Well, if you've got your sticks with
No,
you,
stick, I'll give you a
have a
copy.
copy.
Of it.
Uh-huh.
Yeah.
I'll put one in there.
Yeah, proposed mining projects, that gives a number of different,
I'm quite interested in self-replicating machine idea though.
yeah.
because
That's the thing, send a machine there
Yeah.
that can make copies of itself to make and basically bring back a load of machines.
there's is that von Neumann machine that Chris Boyce used to
Yeah.
talk about in the 70s at ASTRA, you know,
Right,
right?
yeah. Yes, Chris would have
Uh-huh.
given his element of this kind of stuff.
I might have to get you to repeat this in another time, this talk, and video it again if you want it on the internet without the music.
Yeah, got you.
Right.
I could probably take that off for you.
Sorry?
I can take that off for you.
What, the music?
Yeah.
But can you keep the speaking?
Yeah.
Right,
Or did you can do that?
right.
Would you just identify it?
Because what YouTube, it's starting identifying music now and it's copyright. Sometimes it lets you use it, but it'll put adverts in. Other times tell you you're not allowed to use it.
I
No.
never recognised that, it's too out of tune.
Well, it did at Duncan's thing, you know. Robotic asteroid prospector project.
So how do the karaoke get away with not paying royalties?
Because they're not broadcasting it.
They're performing it in front of an audience.
Well, they should have a public performance license if there's more than 4 people
Probably
listening.
have.
Most churches do. Our
Hey, well,
church has
survive must be worth a fortune.
yeah.
Every time you go buy a pub,
We
they'll
have
be
to
able
have a license to sing the hymns at the service on a Sunday morning. It costs us, can't remember how much we pay. You have to have even religious Christian music is copyrighted and you have to have a license because you're performing, public perform. I'm broadcasting this on a TV station globally on YouTube. So that's where the problems come in.
Don't worry, we're spreading the word, not copyright.
Now you will notice there's cobalt in an awful lot of these. That's why I think that will be very useful.
Was cobalt used in early stuff, radiation treatment for cancer? Was it what's his name, Charles Mary Macintosh had got cancer in the mouth or something? And I seem to remember reading something about the doctor.
Actually, we need Graham here for that.
It's a radioactive isotope.
I think Graham would be the person to answer that question, because I think cobalt is used in.
Well, I mean, he works with machines that.
I think it's quite likely the first thing to be mined would be water.
Yes.
Yes, yeah.
You know, once you get off there, the
This is
first
true.
thing that you've got to do is go to an asteroid with water.
And indeed, there's some asteroids like Amor itself the one the Amors are called after, is about 8 miles across, and it's solid steel, and they reckon that it's naturally better quality than Ravenscraig produced.
Is that right?
So, I mean, that would be very, very useful for constructing things in space.
Natural steel. Never heard of
Yeah,
that.
natural steel. And it's very, very high quality, apparently.
Was it hunters didn't beat it, eh?
Oh yeah.
The cracks.
Delivering stuff.
There's apparently cracks in it. Yeah.
Is that right?
Yes, there's
I
cracks
never
in
mentioned
it.
that when I was there.
Yeah, there's cracks in it.
Oh yeah, in the containment vessel
Is that
actually.
right?
Yeah. It was a couple of years ago they announced that.
Well, there must be new cracks in, because this was only the other week they were going on that there's new cracks appeared, you know.
Yeah.
And you know. And they,
I'm sure a couple of years ago they were assuring us, no, the cracks have been dealt with, they're not spreading.
No, you had some stuff, Robert. You
yes,
wanted to-
Next time you go to Hunter's Snook, it'll probably be called Windscape.
Oh, yes.
Get downstairs for a minute.
right, I'll wait till you come.
I'll drop it out for you first.
I'll wait till you come back up to hear the. Right, I'll stop this now and then I'll. Okay, now. I must be getting on for almost 10 years now. I gave a talk to ASTRA about missions to near-Earth objects, because under the Bush administration, the space program was beginning to move forward, and the constellation program, Orion, and the Ares 5 rocket opened the door to sending astronauts to the asteroids. So there was a number of studies done in the early 2000s into flights to the asteroids. This had been possible in the 60s using the Saturn V Apollo, because obviously it never happened. And unfortunately, I can't find. There was a whole lot of asteroids that they had looked at that you could go flights that would take from about 3 weeks to several months to be away. You know, these pictures here are more the recent proposals for what we were talking about, the asteroid mission. The asteroid mission started off as, is there any chance you could kind of leave it on the picture, Bob, really on the first picture, because I want to, if you could go back to the first picture, right, thank you, right. The asteroid mission started off originally under the policy that was, I can never get, this black hole. The guy that Obama brought in to do the review in the space program, what's his name again? The guy that Clinton got in to shut the space program down, and Obama got the same guy, I can never remember his name. And he came out with instead of going to the moon, they could go in this program where they go out in steps. There was a name, what was the name?
I'm not quite sure.
That has a name, right? So, and I can't remember.
Earth, was it Mission
No,
Planet?
not Mission, no, that's separate, right? So, well, what we basically call it is the Mission to Nowhere, but it actually has a proper name. And what it was about was incremental steps. So, you could go send astronauts to the Lagrange points. You could then send astronauts to an asteroid, which was a great, because this is seen as a stepping stone to manned missions to Mars, because nobody in 50 years had been beyond the moon. So this is what they were going to do. There was going to be, it started off in the Bush administration, there was a lot of talk. It went into the Obama administration, they were still going on about it, they were going to go on an asteroid. And in this picture here, you see two Orion spacecraft with the solar panels docked back to each other. And the reason is to give one of these vehicles acts as a hub, and the other one acts as the actual spaceship. So because you're going on a long flight, and it gives the astronauts more room. And the second one also can take over in an emergency if you get like an Apollo 13 type incident and the first one breaks down. So there was a whole list of asteroids that we could visit, you know. And then what happened was that the Planetary Society, who are normally mostly opposed to human space flight, and they were opposed to a return to the moon, they had a big conference, and at this conference they proposed an unmanned sample return from an asteroid. And that is, I'm afraid, what we've been moving to. So then, instead of going to an asteroid, the proposal then was that as an unmanned spacecraft would go to an asteroid and bring it back to the moon, and then astronauts would go and visit at the moon. And that's then been scaled back to, they're not even going to do that. They would go and they would take a rock off the asteroid and bring it back to the moon. And somebody said for the cost of doing that, you could probably get 20, 30 robotic missions, you know, to explore up to asteroids. So anyway, the possibility of going, if we're going to start mining the asteroids, we want to start using the asteroids, colonisation on the asteroids, we've got to make a start to go. And we're at the point now, for the first time since 1973, that we're going to have the technology to do that. Because in America, they're rebuilding Apollo, a better version. So if you have the next slide, Bob. And you need to go back, it's because you went out, you need to go back to use folder and start from the beginning again. That's it. So this is, you can see here the spacecraft. This is another design that NASA did a few years back for a kind of space tug. We've been talking about space tugs since the 1960s. It was cancelled after the end of Apollo. Then they were going to have one in the shuttle, and Bill Clinton cancelled that one. So it's on again. But here it's a small spacecraft, and it's enabling astronauts to visit a small asteroid and take samples. And that's a practice for the future. I mean, we're actually talking about going out and mining the asteroids. The next picture, please. Now, there are different types of asteroids. That's what Mark was asking earlier on. There's the AMORs, the Earth approaching the orbits exterior to the Earth but interior to Mars. So they're inside from about, what's that, 1 astronomical unit, between 1.17 AU and 1.3 or something like that. Then there's the Apollos. They have a semi-major axis larger than the Earth's, named after asteroid 1862 Apollo. So that's between 1 and 1.17 AU. I don't know what the AQ, what I call a perihelion distance and aphelion, right? So they'll come within 1 unit and 1.17. The Athens, with a semi-major axis smaller than the Earth's, named asteroid 2062 Aten, and they come within 1 astronomical unit and within 0.983 of a unit.
Now, I think
the
figures refer to the orbit, size of the orbit.
Of the orbit, right.
So the orbit
right.
is between one astronaut and 0.983.
Or
no.
The perihelion is the first, is an aphelion.
Q is the
always get these two mixed up. Like.
The Algerians are normally not used nowadays because they generally just call them all batches.
Right. So these are basically the year, you know. Right. So we'll have the next picture. Right now, so there's a lot of work done in the constellation program of these missions. It's actually, when I gave this talk at ASTRA, the time period that these missions were actually going to happen actually was now. They would have happened over the last couple of years. So you can see here, like the Earth departure, the spacecraft goes to an asteroid. Your delta V, asteroids arrive at the asteroid, and then you've got a departure, delta V burn again, and a trajectory to return to the Earth at the same time of flight, and some velocity relative to Earth upon return. So you've got the asteroid in the Earth's orbit, so so you go to the asteroid, it's further out in space, so the Earth is going around the Sun quicker than the asteroid, and eventually the Earth's overtaken the asteroid, and then you can depart the asteroid and you can come back to the Earth. So there's been a lot of work done over the last decade on missions to. This would be great because this would be the next big step after Apollo. It's a step towards going to Mars. It's not, you wouldn't be going as far as Mars, it wouldn't take as long, but astronauts for the first time would be going out into deep space. Bringing an asteroid to lunar orbit to me is just silly. And the astronauts we wouldn't be achieving anything we haven't achieved 50 years ago in the 60s. So this would be a big step forward. And if we're going to have to deflect an asteroid, move an asteroid, or we want to go and start mining asteroids, or eventually colonise the people live in the asteroid belt, this is the first stages to do it. Next slide. So this is just a diagram that shows the classic. There's another orbit of one of these inner asteroids, 1943 Anteros. So that was February 11th, 2015. It was 2.344 astronomical units from the Sun. So it's just over twice the distance of the Sun from the Earth, and it was 1.77.1 AU from the Sun. So it's a typical, So even if we had a base on Mars, asteroids come near Mars, we could launch astronauts from Mars or from the Martian moons to visit asteroids that have gone near Mars as well. Okay, next one. And that's just I think I'm not sure if that the last one. It's a graphic of near Earth. That's what Andy was talking about.
Asteroids
passing close to the Earth Moon system. So we're going to get. I would like to do a talk about the Space Launch System and Orion. I did 2 talks about the progress in the commercial space program with SpaceX and Boeing, but there is also a lot of news about the Space Launch System, and we are concerned about what's going to happen to it, because if Hillary gets in, is it going to be cancelled? But not, as I was saying earlier on, Hillary's science advisor thinks that we should be going back to the moon, so we'll need the Space Launch System. And Trump's space policy is to have a space program that is about space, not the Earth, to go out into deep space. So whatever's going to happen, if they've got a big rocket, they're developing Orion. None of the commercial space vehicles that are being developed at the moment are capable of missions to the asteroids, but they could be adapted, Elon Musk talked about Mars missions now of colonising the planet Mars. So if he's developing that kind of technology, then I don't know, has SpaceX, Andy, got any plans for stuff to do with the asteroids? Has he mentioned that? Does he? I know what you're saying about needs the fuel for the electric cars, but has Elon Musk talked about doing any stuff to do with the asteroids?
I believe they have got plans, but they've not been revealing them.
Right.
Actually, maybe we should ask Yuki about that.
Yes.
Because he used to work for Elon Musk. Yuki Takahashi. He used to come to our meetings regularly when he was studying at Glasgow Uni. And he's now with a biological company in California. But his degree's in physics, not biology. So, his doctorate, actually, Yuki's now a doctorate.
Where are the tails on these things point towards the sun?
Because I don't know, it's the artist, Because with comets,
that's speed lines.
it's like a comet.
Actually, that looks a wee bit like Didymos on its moon, doesn't it?
They actually could be on the way out from coming in round the sun, and they could have ice in the ice atmosphere.
But
like a
It's
comet.
gone away from the sun,
Right,
that's one bit.
you can see the daylight side of Earth there, so that's pointing towards the sun, which it should point away, whatever direction it goes. It should point away.
But the comets do that, they develop tails, and the asteroids, some asteroids may have small atmosphere and ice and the isometric.
but not
It's a common
pointing
mistake
towards the
for
sun.
artists.
Well, the artist has got it wrong then.
Yes,
Mark.
that-
to point the tail to show the direction of
That
travel,
orbit
which
you
is nothing
showed
to do
a
with.
few minutes ago, Robert, of Antares.
Uh-huh.
How often does Antares, how long does it take for its orbit?
I honestly don't know where it's there. I don't know. You need to look that one up the internet. Well, wait, it
Would be over a year.
I wonder how big Antares is.
well, it's actual fact it'd be over 2 years because it
Yeah,
goes
it's gone
beyond
outside
Mars.
so yeah.
So Mars is 2 years. So.
But this is what occurred to me is if Antares is big enough, that might be a good one to make your cycling spaceship in.
Yes.
And
That's
limit
aye.
it,
Yeah.
yes,
Uh-huh.
because it comes near Earth orbit and it also
Idea Mars
passes
orbit.
not
That's
too far
very, very
from
good,
Mars,
Andy.
yeah.
That's very interesting. Actually, I don't need to find out how big. Well, the problem next is how big is it?
I will look Antares up when I get
right.
home.
That's
Get
interesting.
more details on
yes.
it. Yes.
So there we go. That was just my little contribution to.
Yes. Anybody else got points to bring up on?
Right, so it's an Apollo.
Yes. Either that or an Amor actually, because it approaches, but I don't know if it comes. It didn't.
No, it says interior to Mars.
Sorry.
The Amors are interior to Mars. They're all within Mars's orbit.
Ah, yes.
And that crosses.
Yes, that crosses Mars orbit.
Crosses Mars orbit.
But Apollo's generally, a lot of them cross our orbit as well. That one doesn't. It just comes very near ours on that orbit anyway.
Well, that seemed to be the closest. It says Earth crossing actually, so it's
Yeah.
not Earth crossing either.
Well, that's why I said maybe it's a Nimmo because they don't actually cross ours.
Doesn't quite fit any of them.
Yeah, that's it. Well, I don't know, the definition I had of Amor was that they do cut Mars's orbit, but that one says they only cut Earth's. Well,
It says interior to Mars.
yeah, they don't cut either of that in that one, yeah. I think
That's right, it's between Earth and Mars.
I think they actually have extended that now to cutting Mars.
Right, so it's probably an Amor.
Yeah. Well, it's like the Asteroids. Nobody mentions Asteroids nowadays. It's all just atoms. Because they're both within the Earth's orbit. Atoms do cut our orbit, sometimes come outside our orbit, but Asteroids, atoms are mainly inside our orbit. Anything inside our orbit generally is called an atom. If it's outside our orbit, but inside Mars orbit, it's generally called an Amor. And if it's crosses Mars orbit and our orbit, then it's usually an Apollo.
Right.
Yeah, that's the pic of the ESA. Well, that was that one. That's the ESA Didymos mission. As you notice, there's two craft, a wee one and a big one. Well, big nearby one. Put it that way. But the idea is one of them will photograph everything the other is doing,
Right.
and including the impact. So they'll have two pics of the impact, both from the thing that's sending the impactor and from the camera thing. That DA-14 is actually
a biggie with a lot of.
Is this the one they thought might come back, but it's not going to?
Well, that was the one they reckoned was 120 something billion.
This one, I think, 2013. Was that another one they thought might?
Million.
Actually, that's a misnomer. It's not the ecliptic plane if that's a geosynchronous orbit.
Sorry?
It's at ring plane crossing point. Oh, projected into the ecliptic
The
plane.
ecliptic plane is the plane of the orbit, Earth's orbit around the Sun, which has nothing to do with geosynchronous orbit. That's an angle of 3.5 degrees.
Yeah, but it says projected onto it.
This
It should be a.
green ring is geosynchronous orbit. The
Yeah.
point is this comes within geosynchronous orbit
Mm-hmm.
and then goes out. And that was basically the reason for that
Within that
picture,
distance, you're saying.
is to, yeah, it comes in within that distance, yeah.
Right.
Yeah. Because geosync is, I can't remember the exact height, but it's quite high,
32,000 kilometres or something.
something like that. And that came within 17,000 or something like that, or 17,100 or something like that. It came very, very close to Earth, and it was a biggie.
Uh-huh. Well, it just says ring plane crossing point. It doesn't cross it. I mean, that's
Well, it does. It's got to cross that.
Coming in at an angle, yes.
It's got to cross that plane at some point.
No, maybe. Hmm.
So what's it? This is mineral, you said.
That was a mixed.
What's it? Fiberglass. I'll phone you back shortly.
Yes, that's the mainly mineral one, X, I think it was, or they call it. Oops.
I'm trying to think what material that looks like, that white.
What's it? Fiberglass.
Like what?
Fiberglass.
It does look like that a bit. I doubt if it is that.
No, it could be maybe something like mica, I think.
Yeah, maybe that sort of thing, yeah.
Natural planes,
Yeah.
like straight planes like that.
Yeah.
Dense enriching minerals, it says one of them has more platinum than has been mined than all the platinum that's ever been mined on Earth.
Well, there could be exotic minerals as well, because of
Yes,
under such
yeah.
radically different conditions. That there could be minerals that you won't find on Earth.
Well, there's possibilities, but we have to go and explore and find out. At the moment, all they know about these things is from what they've analysed meteorites.
Mm-hmm.
I think they'll also find out a lot of them at very different ages. Because I think quite a lot of them are probably being captured by the solar system as it moves up and down the plane of the ecliptic as it passes around the orbits the centre of the Milky Way. So they may well find the odd asteroid that's even older than the Earth.
Yeah.